Okay, so in addition to A, your input-output matrix that you will have to set up, there are some other important matrices that go along with these situations. The first one is the gross production matrix, or a lot of times they just simply call it the production matrix. So this is it's the gross production of the entire economy. So what you would fill this in with is what is the total tons of coal, the total tons of steel, and the total units of transportation that this economy is making. That would be your X. In addition to that, you have what's called the internal consumption vector, often also referred to as the output matrix, Y. And what Y consists of is where all of the products are going. The arrows, this is not going into the sector, but the arrows coming out of a sector. So what is the output of each one of these sectors? This is also the amount of each product used up internally just to keep the other sectors running. So in this case, if we were talking about the output of coal, steel, and transportation, we would go back to our image and we would instead look at what's going into the sectors, look at what's coming out of them. So what's coming out of coal? Coming out of coal, we have this 0.02 coal. It's coming out of coal. So is 2S, and so is 0.01 T. So that would make our output matrix for the coal. So for the coal, what's coming out of it, what I just said was the 0.02 coal, the 2S, and the 0.01 T. Now we can do the same for the rest of them. What's the output of steel? What's coming out of steel? So coming out of steel, here we have, I guess try to do a different color. Out of steel, we've got 0.1 coal, we have 0.01 S, and we have 0.1 T. So as I go back down to what's my output for steel, my output for steel is 0.1 coal, 0.01 S, and 0.1 T. Then finally, what is coming out of transportation is 0.3 C. Where's the other ones? 0.05 S and 0 T. So what's coming out there? 0.3 C, 0.05 S, and 0 T. So there's that output matrix. In matrix terms, so if we put this as an actual matrix equation, what this then tells us is that, I'm going to switch back to my standard blue. This is an important equation, is that y equals ax. So if I wanted to find these y values, where those actually come from is taking the A input-output matrix and multiplying it by the X matrix. So this is A and this is X. And if I were to multiply these, I would end up going across and down, and you can see how is Y1 created? Y1 is created by doing 0.02 times C plus 2 times S plus 0.01 T, right there. And how is Y2 created? Well, Y2 is created by doing 0.1 C plus 0.01 S plus 0.1 T, right there. And then Y3 is created the same way. So we end up with this equation, this matrix equation that we can use, where instead of, you don't even necessarily have to draw it all out. We can just know that if we have the A matrix, if we are given that, and we know our X variables, then we can just multiply those together and say what Y is. So that will be something that you have to do in your homework and on your quizzes and tests, is they will ask you, what is the output matrix? So you can multiply these two together and find that. They may even just ask you the output for a single, like Y1, Y2, or Y3, and then maybe you only need to give them that certain part that they're asking for. But that equation right here is what's super important. Okay. says, remember though, there's also outside demand on these sectors. So they need to produce more than what is used up internally in order to meet the outside demand of the market. So we know if we're given the gross production, we can find Y, and then you can find what's called the surplus by subtracting. So if you take the gross production, so remember again, X is the gross, what they make total, and if you subtract off what they use internally, then what's left is their surplus. That's what's left over to be used elsewhere. Okay, so that's a fairly easy one, but you have to do the other parts first. So here's our example. It says, suppose the gross production, so you have to know that gross production is X, of this economy is 250 tons of coal. I'm just going to go ahead and fill this in. That's 250 for C. 85 tons of steel and 80 units of transportation. So that's their gross production. First, let's find, sorry, there's a typo here. First, let's find that internal consumption vector Y, or that output for each of the sectors. So in order to do that, we take A times X. So now we take A times X here. You can do this in your calculator if you wish, or you can do it by hand, but you're going to multiply these together. So you have to take 0.02 times 250 plus 2 times 85 plus 0.01 times 80 and find out what that comes out to. And that comes out to approximately 175.8. And then the same for the other ones. So 0.1 times 250 plus 0.01 times 85 plus 0.1 times 80. That gives 33.85. And when you take the last row times this column, you should get 79.25. And as a reminder, that's a C, an S, and a T. So this much of each commodity is being consumed just to keep itself running. Okay, so then the question is, what's left over? What's the surplus? So again, if we take the gross, so overall, they've made 250, 85, and 80. Already used up in the process was 175.8, 33.85, and 79.25. So what remains, just subtract these values, what remains is 74.2 tons of coal, 51.15 tons of steel, and 0.75 units of transportation. So there's not very much transportation left over. So that is what's left over for the external demand. So there's a little bit left over for the rest of the market to use.